So systems of linear inequality. You guys, when you have a system, here's why your homework is the way it is. You are basically getting two problems like what we did in the lesson before in one problem, okay? You're going to get two in one. And so what it means is, for each problem, it's still just one graph, okay? But both inequalities are going to be graphed on the same graph. When you have a system and you're asked to solve it, what you want to do is find all the ordered pairs that work for both of those inequalities. So not only do they work in this one, but they also work in this one over here. You got to find all the ordered pairs that work in both inequalities. So it's like two problems in one. So it's exactly what we did before, with a little twist to it. So what a system is. System of inequalities, two or more, we're just going to do two, inequalities in one problem. It's very exciting. So when they tell you to solve a system, they're asking you to find all the ordered pairs that work in both. And I'll show you how we're going to do that, because there's no way to list all of them, because that list would go on forever. Okay, so here's how you're going to do that. You're going to do your graph and your shading for both of them on the same graph. Graph and shade both of your inequalities on the same graph. So when you do that, you need to pay attention to where the shading overlaps. Wherever the two shadings come together, that means those ordered pairs are included in both of the shadings, aren't they? That's what you're looking for. You want all the ordered pairs that are in both of the shadings, and that is where your shading overlaps. Now I'll show you a good way to show your shading to make it easy to see that overlap. You could always use colored pencils and shade one with one colored pencil, another with another different color, and where the two colors come together, that's your solution, okay, that area. Your two lines cross, and they're going to form an X when you graph it. It breaks it up into four separate parts on your graph, doesn't it? One of these parts is going to end up getting shaded, and you've got to figure out what part that is. So the solutions are going to be where your shadings overlap. Can you see it? And we're going to do an example together. Now the directions will be solve. Solve means graph them and show me where the shading overlaps. Your graph itself is going to be your answer. Now I'm going to give you two inequalities that already are in slope-intercept form. So make sure when you get your inequality, if the y is not alone, get the y alone. And I suggest the y being on the left side. All right, on this first inequality, what's our slope? 1. What's our y-intercept? Good, 3. Second one, what's our slope? Negative 2/3. And our y-intercept? All right, so we've got our m and b. So now we need to see how these look on graph paper. What kind of a line will I have when I graph this? It'll be uphill because of a positive slope. Cooper? It'll be a shaded line. I'm going to be drawing a solid line for this one, and it should be uphill with a positive slope. Will I shade above or below? According to the inequality, it's a less than of some kind. Below. You can always use a test point to make sure you're right if you are unsure of that. So start at your 3 on your y-axis, and this means up 1, right 1. You can go up 1, right 1, up 1, right 1. What is your other option? If down 1, left 1. So down 1, left 1. So this is going to split our graph into two parts. Solid line. And you said shade below. If you're climbing the hill, this is the side you're on, so that would be above. So below is this way, and what I'm going to do is just make lines showing my shading to start with. When I do my shading of the other inequality, I'm going to have my lines go in a different direction. So where they crisscross each other, that's your common area. You're looking for that common area. All right, tell me what you know about this second line. Slope is a negative 2/3. Look at your inequality symbol. What can you tell me about this graph? Mia? It'll be a dotted line instead of a solid because you are not equal to. Uphill or downhill? Down. It'll be downhill. Will we shade above or below? Below again on this one. Okay? So let's start at negative 2 on the y-axis. And these are the two different versions of your slope. Since it's negative, only one number is negative. You can go down 2 and then right 3. And I don't have much more room to do that again, so I'll go back and go up 2 and left 3. Oh, notice I land right on that line. Broken line, though, this time, correct? Broken line. Dotted line. That means any point on that line is not a part of that solution for this inequality. Now we haven't done the shading yet for that one. Keep in mind where your line is. You said below, correct? That's this side. So watch how I do my shading. Do I have shading from the other line over here in this section?
Yes.
Right over here? No. I have 4 sections. 1, 2, 3, 4. There's no common shading here, but I keep going below this line. Do I have common shading here? This bottom portion, look at this as an X. The bottom portion is where the shading is overlapping. You have the crisscross. So this is what I really want to make sure I darken, because that is the section that shows where all the common solutions, the solutions for both of these inequalities, are right here. This section has only solutions for one inequality. This section has solutions for only one of the inequalities. This has no solutions at all. This is the one that has both. So the graph itself is your answer on that one. Okay?